We want the other one. We don't want, okay, listen, hold on. Just one pause, I'm sorry. Is that, yes, you could say it's 1 minus sine squared, but that doesn't help you because where are you then? You're just back where you started. You have this, you could arbitrarily keep going and have this chain of 1 plus minus plus. It's nothing, right? You're going to be back where you started.
Yeah.
Instead, you want to write it as what? 1/2 of what?
Times the value,
What? Do you remember what it is? One. What is it? Hold on. When two of you speak at the exact same time, not good. Erica, go. 1 plus cosine of what? 2x. Do you agree with that?
Yeah.
Do people agree with that? We're in a position, can we actually find out what v is? Yes, say yes. Because now we have the integral of 1/2 dx plus the integral of 1/2 cosine of 2x dx. So this is just going to be the integral of 1, so it's going to be 1/2 x plus 1/2 times the integral of cosine of 2x dx. And what's nice is, what does it come out to be? 1/2 x plus, well, it's going to be sine of what? Sine of 2x times 1/4 plus c. Well, we don't, it's okay, not here, it's fine, but yes, you're absolutely right. So, that the integral of, we know the integral of u dv is equal to uv minus the integral of what? V du. Exactly. So we know our integral is going to equal to u times v, so it's going to be x times fx plus 1/4 sine of 2x. So that's uv minus the integral of v, so that's 1/2 x plus 1/4 sine of 2x times what? du, which is exactly what we hope we would have, right? Which is not bad. It's not okay. It could be a lot worse, is what we're saying, I guess.
Relatively pretty.
Yeah. So we have x squared over 2 plus x over 4 sine of 2x minus 1/2 times the integral of x plus 1/2 sine of 2x dx. We can. So we end up with x squared over 2 plus x over 4 sine of 2x minus 1/2 times x squared over 2 plus what? Or excuse me, minus what? 1/4 cosine 2x plus c. How confident we are in this answer? We pretty confident? So if we wanted to, yeah, exactly. So these two right here, it's just because it's x squared, turn into x squared over 4, because it's a half of an x squared minus that. So plus x over 4 sine of 2x minus, or plus 1/8 cosine of 2x plus c. So again, this is a very, very specific path. When you're doing integration by parts, you need to pick a dv that you can integrate, and usually you wouldn't by choice choose something like cosine squared to integrate. But you should now know in your head, it's not nice, but can you integrate cosine squared x? You can. It's there. You need to know the paths. Like, for example, to be perfectly honest, do I immediately remember all of the inverse trig derivatives? Not always, but I know that they're there, and I know that when I can, if I see it, I'll recognize it. Can I pull them out of thin air all the time? Not always. But do I want you to be able to do that? Absolutely. Can we write this as definite integral of cosine to the 5th theta over sine to the 5th theta times sine to the 4th theta d theta, and is actually something nice that happens here. Oh, relatively nice. Do we want to get rid of that? Yeah, I know. It's really tempting. Like, you really want to do it. Well, let's see if it'll help. So what do we end up with if we do this? You know, it cancels. Yeah, you end up with, well, cosine to the 5th theta times what? Secant theta d theta. 1 over sine is cosecant. You're absolutely correct. Okay. Yeah, so let's do that. Let's see what happens. So you want to turn it into cosine to the 4th theta times cosine theta times not secant, cosecant. And we like writing it. Cosecant theta, d theta. Okay, I like that. Cosine squared, right. So now we have cosine squared theta squared times cosine theta times cosecant theta d theta. But what is cosine squared? 1/2 of what? 1 minus sine of what? Isn't it sine of 2 theta? That's the whole point, right? Yep, 2 theta. And we're going to have to do what to that? Square it times what? Cosine theta times cosecant theta d theta. So what do you think that is? What's going on there? What do you see a lot of in there? I see a lot of sines, and I see the derivative of sine in there. So what method might we be able to use? Yeah, if we let u equal sine theta, we know that du is equal to cosine theta d theta, right? So what does that mean we now have? We now have the integral of 1 minus u squared over, thank you, get very angry there, I see. But what do we have? We have d theta is equal to, I'm sorry, let me write the whole thing out. I don't want to be lazy here. The whole thing out, so it's cosine theta times du over cosine theta, and what magically goes away? The theta goes away. And now we're left with 1 minus u squared all over times du. Okay, so now the question is, what do we do with that? I'm glad you went to that quickly, because sometimes you learn these new tools and you just want to keep on repeatedly using the same tools again. You should always remember, you can always simplify, and sometimes you're not going to have to use any of the tools. Don't forget, when you first started learning how to integrate, you could just integrate by looking at it, right? So you expand this, so we like what we see now. We definitely like what we see, and we turn it into, so you can see it while we do it. We end up with 1 minus 2u to the squared plus u to the all over. And you're doing the integral of this du. So what do you end up with? Yeah, you end up with u to the negative 1 minus 2u, right? Plus u to the... Now, what does it turn into? Not integral. What does it turn into? Okay, so here we go. Oh, good. Thank you. So here is something that's not trivial. Let's say I asked you to find the integral of the square root of 9 minus x squared all over x squared dx. Don't try to do this with paper. Just let's think about it for 1 second. What problems do you see? What is, there we get 9. Oh, look at that. We end up with the square root of what? 9 minus 9 sine squared what? All over. We'll keep this one here. 3 sine theta squared dx. What can we factor out in the inside of the radicand up there? 9. Yeah, I understand, but I'm factoring it out first. So, you want to pull it all the way out. That's cool. That's cool. So 3 times the square root of what? Sine squared theta all over 3 sine theta squared. We're still in dx. We haven't taken care of that problem yet. But what's the nice thing that happens now? Cosine squared pops in. So now we have the integral of 3 times the square root of cosine squared theta all over the same thing here, sure. But what's the cool thing that happens? Oh, it's a square root of that. So what are we left with? 3 cosine theta over 9 sine squared theta dx. We can't really go anywhere yet because we have a mismatch of variables. So hold on, just to recap everybody. We did the substitution, which allowed us the key thing, which it got rid of this really annoying thing. It got rid of this square root. And then the substitution worked really well. And now we're looking for the integral of cotangent squared. Now what do we divide everything by if we want cosecant to come out? Sine squared, and sine squared. You end up with what? 1 plus what? Cotangent squared theta is equal to cosecant squared theta. Exactly. Good. So now can you integrate this? The derivative of what is cosecant squared? Thank you. Negative cotangent theta minus what? Theta plus c. Hold on, we're not done. We're not done yet. Remember what I said when I was sitting down right there? Does it matter what we substitute for x? No, as long as, what do we do at the end?
We bring it back.
As long as we bring it back. And let me just verify 100% certainty that this is good. Yeah, we're good so far. So we need to bring it back. Now, what variable were we dealing with to begin with?
X.
It does not look very nice. So if sine of theta is x over 3, what does that triangle look like? Sine is opposite over what? So x over what? So what is this base going to be? No.
9 minus x squared.
9 minus x squared? The square root of what?
Square root of that, yeah.
9 minus x squared, because you need to square that to get 9 minus x squared? Oh, okay. So what are we looking for now? We need the this is theta, do you agree? Right there? So now we need the cotangent of theta. So what's that going to equal? Negative, cotangent is 1 over what? Cotangent, sorry, cotangent is cosine over sine. No, hold on, you're thinking of way too much. It's cosine over sine theta. That's fine. So what can we write this as, unfortunately? Theta, you know directly just equals sine inverse of. And that's all you can do to get the next part. So you're going to end up with minus sine inverse of x over 3. So that carries down, and you're left with this minus sine inverse of x over 3 plus c. You just figured out the nastiest indefinite integral you've ever worked on so far. Yay! First, we're going to need to set this up a little bit and make it a little bit easier on you. So you have a nice ellipse. That's not a very good ellipse, and I think there's an ellipse drawing too, but I'll just try to. And I keep on doing it at an angle. Yeah, there is, but you know what? I'm just going to do it like that and keep it at an angle. You got it. No, it's terrible. There we go. Okay, so there's your ellipse. And what you actually know is what you can say is you can actually figure out what, if this is the formula right there. Which one's A, which one's B?
Well, if x squared equals 0.
Yeah, you're looking at this one right here. You're looking at this one right here. So what would be the integral you need to set up? That's the integral from, yeah, so just that one. So it's going to go from 0 to A, if we're going to be in terms of x, which seems like we can do that. That seems okay. Now we need the height function here. What's the height function of this going to be? So we have an integral to evaluate. That looks nice. It doesn't look impossible. Does it simplify a little bit? Does it simplify at all, kids? It doesn't simplify at all? It simplifies some, right? So what do you end up with? I don't know, the integral from 0 to A of b times this. Oh, you actually need to see what's going on? That would be helpful. Give me this times x squared over a squared dx, right? And then I see equals 0 to A of b times the square root of a squared minus x squared over a squared dx. And then you can say b over a, you can factor it all the way out, right? Because they're constants, times the integral from 0 to A of the square root of 1 minus, is it 1 minus? 1 minus x squared dx. Does that look like it? No? Is there something? Ah, okay, we have to be real careful here, right? No, it's okay. Hold on. So what did you end up with? 0 to A, b over a, thank you. B over a times what? A squared minus x squared. Girls in the back. So you have b over a, integral from 0 to A of this, like that. That's cool. So what should we do for a substitution? We should do xb. Ah, there you go. X equals a sine theta. So you end up with, and remember these are x values, so we can go into, we have to be careful of our limits of integration now, but we have b over a, an integral of a squared minus a squared sine squared, like this. We'll take care of it in pieces, it's okay. What gets factored out? What gets factored out? What gets factored out?
No, it's EX.
Is it still dx? Thank you. We haven't changed it yet. So you're absolutely right. Got it. So it's a times the integral of
1 minus
sine squared theta. What is 1 minus sine? This is hard. I mean, in a way, it's good that my mind is like, this is wrong. This is wrong. So it's right now, brain. It's okay. So what do we end up with? B over a squared.
No.
Oh, B. Oh, it cancels. Oh, isn't that cool? Look at that. That's cool. So we have B times cosine what? Theta dx. But what is dx equal to? Cosine theta d theta. So unfortunately, where do we have to plug that in? We have to plug it in down there. So what are we left with? B times the integral of what? Cosine theta times, is it A? Yep. A cosine theta d theta, right? So what factors out? We end up with AB times the integral of cosine squared theta d theta. Well, we don't like cosine squared. Well, hold on. We only have to change our limits if we're going to actually evaluate it in terms of theta. We could go all the way back, is what I'm saying, if we want. We're not done integrating yet. Let's just integrate and then work about what is cosine squared theta? Well, we want to integrate this thing, right? So we better do it as the one we can integrate. If we substitute in 1 minus sine squared, can we integrate that? Not so much. What can we factor out? We have AB over 2 integral of 1 plus cosine 2 theta d theta, right? So let's actually integrate this thing. We have AB over 2 times what? Theta plus, what do we want here? 1/2 sine 2 theta d theta. Is that correct? It is. Oh, there's no d theta anymore. Thank you. Yes. Okay. That's nice. Wonderful. So now the question is, what do we do from here? Well, we don't know what our limits of integration are. What? We could put x in again. What does x equal? A sine theta. X is equal to a sine theta. So what does theta equal? The sine inverse of something? Yeah, not nice. So we have to, originally we were going from 0 to a with x values. But what does x equal? A sine theta. Okay. So let's actually do the transcription here. If we do this out, maybe something nice will pop out. So we just got one quadrant, so the final answer is 4 times AB pi over 4, which is, how cool is that? I think that's really cool. And you just used calculus in a really deep way to prove a 3-symbol formula. I think that's pretty cool.